determine whether the series is converging or if it is diverging. And we say that if limit is less than 1, the series is said to be converging. And if the series limit is greater than 1, the series is said to be diverging. And finally, if you get your limit which is equal to 1, then the test for convergence or divergence fails. So the test fails. So let's today maybe look at this using this root test. And the root test, you will get your series that you are given, and it's absolute. You find this any the root of it. So for example, you are given a summation from this, so to power n. What you normally do, this is your series. It will be n squared over 2 power n. Then you find the n at the root. And this, remember, it is limit we are looking at as n approaches infinity. What you normally do, this one, as you know, instead of looking for square root, you are able to find, if for example you are looking for square root of 4, it is the same as just taking the 4, then you find this is the same, find the power of that. So once again, it will be n squared over 2 power n, then it's absolute. You are looking, it's this n at the root. Remember, it is the limit as n approaches infinity. So what are we getting? So let's just open this, and it will be very simple. On opening, you get it is n squared, and you are multiplying with this 1 over n. So I think you are able to see that you are multiplying the powers. Then the other side here, 2 power n, you also open by multiplying with 1 over n. So this one cancels with this, and you get that it is limit as n approaches infinity. Here up you are getting it is n power 2 over n all over 2. Remember, the n has cancelled with the other n. So what are we getting? When you reach this point, at this point you replace, remember we are saying as n approaches infinity. So you replace, whenever you have n, you replace with infinity. You are going to replace n with infinity. So whenever you have n, you replace with infinity. It will be infinity power 2 over infinity over 2. And remember, if you divide n number with infinity, you get it is 0. So 2 divided by infinity is 0. And you'll get that it is infinity power 0. And remember that anything power 0 is 1. So numerator will be 1 over 2. And I think the series now is converging because you are getting the limit as half, and half is less than 1, because we said if limit is less than 1, the series is said to be converging. And the radius you are getting is 1 over limit, and the limit, remember, is half. So what we get is that it is 1 divided by half, which you are getting it is 2. So our radius for this series will be 2. Let's check example 2, which is summation of 2 power n. This will be our series. Remember, we are dealing with infinite series. So it is 2 power n, and we are going to use the same approach. We said it is the root of a given series. So it will be nth root of this series, and the best thing that you can do, just let write it like this. So it will be limit as n approaches infinity of our given series, which is 2 power n, and it is the absolute value. Then instead of taking the root, you just multiply by power of 1 over n. So limit as n approaches infinity would be 2 power n. You are dotting with 1 over n, and the n cancels and you are remaining with the 2. So our limit for this case, you are getting it is 2, and if the limit is greater than 1, we said that the series is diverging. Since if limit is greater than 1, the series is said to be diverging. It is diverging. So our radius for this case, we said the radius is 1 over limit, and if limit is 2, then the radius will be 1 divided by the 2, which you are getting it is half. So this is how to do this. It is very simple. Uh, in the next class, we are able to solve other questions of this sort. This was all about the root test. I remember we dealt with ratio test, and we found that the first sample gave us a converging limit, but the other one has given us a divergence. Next time we shall deal with one which maybe the test will fail for testing whether it is a divergence or convergence. So this is how to deal with such simple questions on infinite series. So just keep welcome, keep tuned.